Hello and welcome again to one of our conversation pieces, and we're back to EV charging points, and there's two reasons for that. One is we are currently researching in the development of our course on EV charging, which will be hitting the street soon, won't it, hopefully, Gary?
Well, we're working on it.
But the more compelling reason is that the original video we did answering a question about EV charging point options in terms of earthing provoked quite a few comments. Some of you really liked it and found it useful, but electrician 1541, catchy little name, you should work on your name, said this. This video has confused me more, and that's never helpful feedback for us. We don't like that. But he does say, so if it's a TNCS, you'd put a supplementary earth rod in the connection to the MET.
We did say that, yes.
We did say that.
If you haven't seen the video, it is worth watching.
That was what we seemed to propose in that video. However, he says other videos, don't know where he's watching other videos. Are there other videos? Anyway, are saying put the earth rod in and connect it to the outgoing side of the charger, keeping it separate from the feed CPC. Now we know exactly where you're coming from on that one. We've seen those videos, and there is a point to be made here. So let's revisit, Gary.
Yeah, we should look at that. We did actually cover that.
We did.
In words, but didn't show the pictures. I think we wanted to clarify a couple of points.
So what we're going to do in this one is just revisit that and make it hopefully a bit clearer, and then take it on a bit further, because there is confusion around this. There is no doubt about it. This is causing more discussion in those videos and on the forums than pretty much any other subject. So let's try and get to some definitive answer.
Okay, so we're in section 722.
72.411.4.1. And we went through the there's four options, three numbered options and then a fourth in the next reg, as to how you can deal with the earthing on vehicle charging points.
Yes, predominantly we're talking about the issue of PME. And what does it state there? A PME earthing facility shall not be
used as a means of earthing for the protective conductor contact of a charging point located outdoors, or that might reasonably be expected to be used to charge a vehicle located outdoors, unless one of the following methods is used. Now the first one really is looking at the three-phase side of things, which we feel isn't going to affect a lot of the domestic installs.
Well, not for the short time, but there will be maybe for the long time for fast charging.
Yeah.
But when you come to look at the requirements in that situation there, and we did cover this in the last video, is that you've got to monitor the loads and how they're balanced. And I don't mean for a day or popping in sort of a couple of times a week. This could be 4 months, because you've got different cyclical loads, winter, summer, different times, shifts and all that sort of thing. So it's pretty difficult to do. And if you
look at the guidance,
this is the IET's Code of Practice, fantastic book and is well worth getting. But even there, they make a note about three-phase supplies.
Because they're talking here about 6 to 12 months load profile monitoring, which in itself is going to be a difficult and expensive thing to do. Yeah. But even having made that comment, it says Regulation 72.411.4.1 Part 1 can be met for three-phase supplies if the three-phase supplies are evenly loaded. And again, we mentioned that as well.
Yeah. Right, what's the second one?
So the next one was the main earthing terminal of the installation, connected to an installation earth electrode by a protective conductor complying with Regulation 544.1.1. So we took that and had a look at that. And this is all to do with the business of potentially losing the pen conductor, a break in the pen conductor, which would leave the installation vulnerable.
Yes, it does. Basically, you have your supply coming in and it would return on the neutral, but if you have a break on the supply cable, it would come back, hit on the link, and then pass through and try any other route to return back to that transformer. And because this is connected and electrically passed through, the vehicle would be charged, and if somebody was in contact with that, an earth and or another earth, you could end up with a fatal electric shock.
So the suggestion in this paragraph is that to mitigate that situation, there would be a supplementary earth electrode. Now what we have to do here is draw a clear distinction between that and a TT earth electrode.
Yes, and the requirement is for the main earthing terminal to be tied down to an earth electrode at that point. This is still TNCS, not TT. This is to help reduce potentials if you lose the neutral and it just ties everything down. There are other longer term issues to look at this, so we might have foundation earthing, but because we have lost metallic pipes for gas and water because we've gone to plastic, we've lost all these parallel earth paths. So it's something that was helped mitigate the risk.
Now, all the discussion that's going on out there is to say that where we've positioned that wouldn't necessarily be the place where people are putting it.
Well, I think, and having been told about these videos, I think they are trying to move away from this because it's quite difficult to achieve the values, because when you look at the IET's code of practice, which is still very good by the way, it talks about the current and the loading of this, the installation, and if you look at the values, if you've got 10 amps, which is basically just over the 2 kilowatts, so it's an assumed load here.
And that's a low charging current.
That is. I mean, if you think about it, and if you've got other loads as well, you know, put it all into that, you would need a resistance on that electrode of 5 ohms.
That's difficult to achieve, but when you go up to a fast charge current around 63 amps or 60 there, 1.4 ohms.
And this is made reference to in another paragraph at the bottom of the page, which is with soil resistivity and the length of rods and the combination of 1 or 2 or 3 in connected together. They demonstrate that in many installations, and you said earlier, could be most, and I think that probably is likely to be the case, it will not be practicable to achieve the required electrode resistance. So it's almost saying that that's out as well.
And that's in addition to the other problems of banging in earth rods and potentially damaging supply.
Well, we
pipes
can
and
talk,
such.
yeah, that is. You've got maintenance issues and corrosion, so yes. But this is to do with the 70 volts touch voltage
Yes.
that has come up, and we talked about that heavily in the other video.
Yeah, so we're not going to go back over that. If you want to look at that, we look at the other video in this subject. So we got that one. So the third one was this device, protection against electric shock provided by a device which disconnects the charging point from the live conductors of the supply and from protective earth in accordance with regulation 543.3.3.1.
Yeah, you know
Read it
the thing.
yourself.
Yeah, I mean, we sort of touched on that in the last video, Dave, where the device didn't exist, and it was in Amendment 3 as well, so it was, you know, pre that one, Amendment 2 it came out, but it never existed in the hope, and it was all about numbers and who would be able to manufacture this and get it all into sort of circulation and use. Now, through innovation and entrepreneurship, there are a number of individuals, organisations that have been working with this. I'm not going to say it complies with all of the requirements of that one, but it certainly has, from what I can see and have read on the internet, that has a lot of technical ability to make things safer, and we need to watch this space to see if it's sort of...
In a nutshell, what these devices do is they detect that the PME is broken, they will then disconnect the supply as required by the reg, and then some of them will actually notify you and possibly the DNO that that's happened as well. So they're in a good direction.
Yeah, everything's moving forward, but we need to sort of get this in sort of writing and talk about the safety features. So, you know, I'm not saying it's been sorted, but it's evolving and getting better.
Yeah.
Now, the thing that the gentleman that wrote in was Mr.
Yeah, so he said
1541.
connect it to the outgoing side of the charger, keeping it separate from the feed CPC.
Okay. Now, this is completely different to the requirements that we talked about. This option is taking a PME TNCS system and making it TT, a bit like we see people put for sheds or outside garages and supplies. We are completely breaking...
We're separating the two systems, really. This becomes a TT installation.
Yes,
this
it
becomes...
does.
Yeah.
Okay. So, I mean, it's a little bit difficult to see for lengths of cables here, but this particular cable could be an SWA cable as an example. And basically what we would do is we'd have all the overcurrent protection in the origin, and the arm ring would be earthed up on the installation.
Yep.
But when you come to the EV charging point, the earthing arrangement would be via an earth electrode, which is nothing to do with tying the main earth into. This is completely separate.
And so the onerous task of getting that resistance down would not apply.
Wouldn't apply.
Yeah.
So because you made a TT arrangement, we are looking at normal arrangements, so typically less than 200 because it can become unstable. But as you touched on a moment ago, is that if you bang that into the ground, you've got to worry about drains, gas pipes, other services, plus the maintenance issue, plus corrosion. So, you know, and if you've got a lot of concrete around, it's going to be very, very difficult to sort of get these in. So this is an option, which, as I will show you, is helpful when you lose the neutral, because current comes in and goes back, there's a broken circuit there, it passes through to here, we'll carry along to the cable. Because it's separate through an insulating gland or something, this would not be presented at this point here.
But regardless of the business of driving in a spike and whatever, we still have the proximity challenge.
Yes?
If the distance between this installation and this installation is too small,
There is a requirement in 7671 that deals with this, which is basically simultaneously accessible.
Yeah, there we go.
All right, this is in 411.3.1.1, exposed conductive parts, simultaneously accessible exposed conductive parts shall be connected to the same earthing system.
Yeah. This is to avoid the possibility that you could touch the two. And you can do all sorts of speculative calculations about how big that distance must be. You know, if this charging cable is up to 10 meters, maybe.
There is in the code of practice which explains all of that, and basically most people go on a reputable 2-day training course. There are options for one, but obviously depending on your speed of learning, it would all be picked up in that. But you've got a very long lead, plus the length of the vehicle,
and then the span of the man,
and then the span of the woman. Yep, and you could be touching an outside wall light or something. You know, it gets a little bit silly. I've heard people say, well, if I build a wall between two houses, but you've got to climb the wall.
Charge my car in a well.
Yes. So there are issues there. It's not covered in 7671. No. It is in the IET's code of practice, so it could be an option, but I'm not saying it's the safer of the two.
Call me an old cynic, Gary, but I'd say that this particular issue hasn't been accurately nailed yet, has it?
No.
We need work on this, don't we? This is not clear.
No, I'm sure everything in life is work in progress and things are being done to address this. But this is an option seen by many to help alleviate a potential problem.
So you think that most of the installations going in at the moment are most likely opting for this TT arrangement?
Yes, I think listening to and reading options, a lot of DNOs, a lot of suppliers have gone down the TT route because they don't want to have that issue of a risk of losing the neutral and having a fatality on their hands. So it is an option, but there are other issues, as I've covered and we've talked about, the proximity and the corrosion and the maintenance and side of things like that, and obviously banging in.
For the sake of completeness, as we mentioned in the other video, there is a fourth option, which is the isolating transformer. But we said to get a decent current would be an expensive and quite bulky option, and not likely to be.
Yeah, the isolating transformer, starting at the basic sort of 16, 18 amps level, I think is around about 180, 200 pounds, just for the kit. I mean, obviously you've got installation costs on top of that, but you start going up to a 32 amp and you'd be sort of several hundreds of pounds. And if you want a super fast charge, 3-phase, 63 amp, you could be 1,500 pounds. You know, it's expensive. So you've got the size of the transformer, plus you might need some consumer unit changing arrangements. Again, it's not, you can see why people want to go down the PME route because it's so easy to get to, but we've got to manage this situation, and these people that have been working with safety devices, let's see if we can work together and make it happen.
That's the most promising option for the future, isn't it? Okay.
Can I just talk about this? Because obviously what's not clear here is, because it's such a small graphic, is that we've got the overcurrent protection at the origin and in the charging point, and various manufacturers will have monitoring devices and protective devices and RCDs, MCBs, could be RCBOs, and I've seen various arrangements. This particular one would need to be, for the RCD, at least a type A or a type B, which is more expensive, and this is because of the DC current that could flood into it and you wouldn't get the protection. So that would be another subject for another day, I'm sure.
Yes, we have a question about it. Another question. So we'll do that in another video.
Another video, okay.
Super dupe. Okay, hopefully that's put a bit more clarity into what is, without doubt, a very confusing situation, but it has offered you some options and some solutions when you're faced with the challenge of putting in an EV charging point. Yeah, and that's all for no charge. We hope you found that useful. If there's a subject you'd like us to talk through or a question you'd like us to examine, then why not send it to us? Dave Austin at learninglounge.com will get to me, or you can put the comment in the box below.
And don't forget, you can find more questions on our website, learninglounge.com/18. And you can get even more questions if you subscribe to one of our courses.